In this video, we're going to further explore the whole idea of slope. I have included a page at the very beginning and a page at the end that we're going to complete together in class, so you will just skip over those during the video. This is that first page that I referred to that we're going to skip. The steepness of a line is determined by its slope. So whatever my slope is will communicate to me how steep the line is going to be. If I look at a line, for example, y equals 7x plus 1. If my slope is a whole number, remember slope is the number right here in front of x. If it's a whole number, then that tells me that my line is going to have a large amount of steepness, because the slope is a whole number. It's a high slope. But if I look at a line, and the slope is a fraction, then I can expect that my slope is small, and so my line will not have very much steepness. So the first picture there, the roller coaster has a great amount of steepness. That would be a whole number slope. In the second picture, the bike rider is on a road with a small amount of slope. So I would expect that that line would have a fraction in place of the slope. The slope also tells me about the direction of my line. If the line slants in an upward direction across the graph, and when I say an upward direction, I mean if I read my graph starting at the left and moving towards the right. As I look at the line that way, if it slants upward, then the slope is going to be positive. So, for example, y equals 2x plus 3. The slope would be positive if the line slants in an upward direction. But if I look at the line and it slants in a downward direction, again looking at the graph from left to right, then I know that my slope is negative. So, for example, maybe y equals negative 2x plus 3. The number in place of slope would be negative. Now, I want you to think for just a minute. If a line had zero slope, if the line had zero slope, what do you think that it might look like? We said that a line with a whole number has a very steep slope. We said that a line with a fraction has a small slope. What do you think zero slope might look like? Draw a picture on this graph here before you submit to Seesaw. So let's look at the line that's already been graphed here. It's going to have a positive slope because it slants in an upward direction. It's going to have a whole number slope because it has a decent amount of slope. So let's find the slope. One method would be that we could count our rise and our run. Remember, we said slope was rise over run, so let's count. We rise 1, 2, 3, 4, 5, and then we run 1, 2, 3, 4. So we could say that our slope is 5/4. Now you may say, well, that's a fraction, but consider that fraction. That would be a mixed number, right? 4 would go into 5 one whole time with 1 left over. It's really a slope of 1 1/5. Now we never want to write slope as a mixed number. We want to leave it in this improper fraction form. But I do want you to see it is a whole number slope, so that line does have some steepness to it. Now there's another way that we could have found slope. What's the ordered pair that goes with this first point? We go over 1 on the x-axis and up to 2, so it has an ordered pair of 1, 2. The second point has an ordered pair of 5, 7. I could use those two ordered pairs to find slope instead of counting with my fingers the rise and the run. If I want to use those two ordered pairs, I'm going to use this formula here. I'm going to take the two y-coordinates and subtract them. So I'm going to subtract this y-coordinate and this y-coordinate. 7 minus 2. And then I'm going to subtract the x-coordinates. 5 minus 1. 7 minus 2 is 5. 5 minus 1 is 4. Notice I got the same slope here as I did over here by counting. So let's try finding the slope of this line. Let's simply count our rise and our run. I'm going to start here in the middle, at the bottom. I rise 1, 2, 3, and then I run backwards 2. So to show I ran backwards, I'm going to use a negative 2. Let's say that someone else decided to start at this point here, and they counted down. You would go down 1, 2, 3. So I went down 3, and then I went forward 2. Those two answers are the same thing. They are both a negative fraction. That's 3 over 2. It doesn't matter that the negative sign's written in the denominator here and the numerator here. Those are both negative 3 over 2. So in other words, it doesn't matter if I count up and backwards or down and over. It provides the same answer. Now let's go back and use the formula to find our slope. Let's take the two coordinates that I started with originally. This bottom point is at 6. Whoops, sorry about that. This bottom point is at 6, 0. Let me fix your page here so it's not crooked. Your bottom number is at 6, 0. And the next point up is at 4, 3. So let's find the slope. Let's subtract our two y-coordinates, which are 3 and 0. So 3 minus 0. And then let's subtract our two x-coordinates, 4 minus 6. 3 minus 0 is 3. 4 minus 6 is negative 2. Notice I got the same answer. What if I change these subtraction problems? What if I did 0 minus 3 on top and 6 minus 4 on the bottom? I would get negative 3 over 2. Notice again, I get the same answer. So the order that I subtract the y-coordinates isn't important. What is important is that I subtract the two y-coordinates on top and the two x-coordinates on bottom, and that I subtract in the same order. If I start with this ordered pair, if this is my first ordered pair, then I need to subtract in the same order both times, either top minus bottom for both the x and the y, or bottom minus top. I have to go in the same order each time. Now, let's try just using the formula. Y minus y and x minus x. So, in number 1, let's go in this order. Let's go 10 minus 3, which means I have to go 11 minus 5. The slope of this line would be 7 over 6. If you want, you can go in the other direction. Here's what I mean by that. Let's go 3 minus 10 and 5 minus 11. 3 minus 10 is negative 7. 5 minus 11 is negative 6. What's a negative divided by a negative? It's a positive. So this slope is 7 over 6. I did get the same answer both times. even though I subtracted in different directions on each example. I want you to try this one. You try finding the slope for the second example. And this is the final page that we're going to skip and fill in together in class.